Hello all, welcome to my channel. I'm Raju Pujala. In this video, let's see how we can run multiple models in parallel. So in the previous video, we have seen how to run multiple models using a function, but this time we will see how to run them in parallel so that we can use our available core, CPU cores and RAM memory very effectively. So let's jump into the collab over here. So let's run multiple models using parallel delay. I'm going to consider the same data set. So let's start doing everything from beginning. Okay, df is equal to pd dot read csv. Okay, low memory is equal to false. Okay, so df dot head. Okay, so let's x is equal to df dot drop columns target axis is equal to. Please do watch my previous videos if in case if you are new to my channel and if you are watching this video directly. Um, okay, so I'm so sorry. I was going a little fast and did mistake. Okay, now let's take a look at x and y. Let's split the data from sklearn dot model selection. There are many ways on how you can split the data. It's up to you. I will show you like two more other ways in the upcoming videos. Believe me, guys, I have a repository of like 150 to 200 repository of content which is sufficient to make for 150 to 200 videos. I'm not trying to scale you like oh, these many videos, but all of them these are like really helps you to get into a good nice role. Train test split xy test size. Um, random state 42 stratify is equal to this. If in case if you're looking for in-person trainings, please um, please refer my please reach out to me through my email address. I'm very much happy to help you. I'm doing special classes as well for the people who are interested to learn in person so that I can clarify every doubts that you do have. Okay, so let's run let's do this one. Let's I mean models model training. So what we can do, let's import the libraries first from sklearn dot neighbors. Import k neighbors classifier from sklearn dot ensemble. Import random forest classifier from sklearn dot svm. Import linear svc from sklearn dot linear model. Import logistic regression. Okay, let's create a dictionary. Basically dictionary holds keys and where keys and models like functions. So knn. So I'm just copying and quickly pasting it over here, guys. So I'm doing this on a weekend, so I hope you will like the content. So I'm so instead of giving some rest to myself, I'm doing these videos. Please drop me a feedback. So let's run the models here. So you can see the names, the keys and the functions here. Okay, now define, let's do this one, define model name comma model. In the previous video we have used a dictionary. If you see in here dictionary, this time let's go ahead and do something straightforward. Define train model name comma model. So model dot fit x train y train model dot score x test y test. So I would like to have hold this as a score here, and I would like to return um, the model name the score. Okay, so this is straightforward, but the only one exception here. So instead of just returning the score itself, I mean, we have four models. I should know like which model it is. I'm returning the name of the model as well. Okay, so we have written the function over here. We can, I mean, simply it's like we can directly call here, but rather, you remember here it's a dictionary and we have used the function. And as of now, it doesn't know what is a name and what is a model. So let's see here. So I'm going to use this one, for name, comma, model in for name, comma, model in models dot items. Okay, so name, comma, model in models dot items. Okay, and here keep everything in over here. So what could be the output here, what should done? So for this one I wanted to run this one. So basically here, whenever it runs here, then the it for each and everything it has to run here. So train model, I'm just getting here this one, name, comma, model. So now what does it mean is that this is a function, but so first this runs and the output it comes to here and this runs. So for each and name and every model, when it goes to this one, for example, when it runs for the first time, it will take a KNN and KNN neighbor classifier, and the model here is a KNN and KNN and dot score. And so once it, I mean, from here. So I'm so sorry for that. From here, it picks the name and model. When it runs for the first time, the name would be KNN and the model name is with neighbors classifier, and it will pass the name and model to this function train model, which is defined here. Okay, second, third, fourth, and five. Okay, so this helps to run everything in parallel. No, not yet. So I have to do. I'm going to do a delayed keyword here. Okay, and parallel, right here, and I'm passing something like n jobs is equal to -1. So this is similar to low memory is equal to false. So now what will happen? So it will happen, it will run everything in parallel until the system is ready. This delayed function will help to delay it. So, but if you, I mean, if you notice, we have not imported this yet anyway. So let's import from the joblib, from joblib, import parallel, comma, delayed. So this one, it's already over here. If you see, there it go. In our first video. Okay, so I would like to name this as results. Okay, so let's calculate the time as well, how much time it takes. Let's run this one. So now everything is running in parallel. Okay, so it has completed in 4.18 seconds, which is like very fast. Now let's do this one. So this results, if you print this results, what it has this value and it has this one. So let's consider this as a name, for name, comma, score in results. Let's say print f name score. Okay, now you can see that KNN, it has its score is like 0.59. Random forest here it came back and it is like 0.83. SVC is 0.80. SLR logistic regression is 0.80. So out of all this, if you look at each of everything individually, random forest classifier wins. But again, you can use logistic regression and SVC. Now you might get a question that why, I mean, why I have to pick a logistic regression when I have random forest which is performing high. So there is something called hyperparameter tuning that I'm going to talk in the next upcoming videos, which helps you how you can hyper tune each one of these models to improve the accuracy. So that's all about this video, guys. But do remember that whatever you do, you have to do it in an efficient, and so there is something called optimization. So this parallel is something that really helps, but it is like really confusing. Even I am using a system which is next to me, and whenever I get confused, I refer to the code over there and I type it here. So this takes some time, but If you have everything in your repository, you can quickly refer to it whenever it is required. So that's all about the learning. It's not all about remembering, it's all about like keeping a repository with you. Thank you for watching this one. Have a good day.